Okay, you guys are on.
So we built a device, and it's designed to measure and record acceleration. This is for the Intel WAVE Research Lab. The WAVE Research Lab studies tsunami waves, and one of the ways that they want to measure the impacts from those tsunami waves is having something more localized, so they can measure the impact like right as it happens. So our device is going to be part of, it's going to be attached to something, and it'll be ready for the wave when it hits. And they'll record a series of tests and use that data to help prepare coastlines for tsunamis, build structures, prepare for those types of disasters. So that's just kind of a summary.
Does Andrew know anything?
Yes.
Andrew knows quite a bit, yeah.
So,
what could you add to that, Andrew?
We ended up using two different accelerometers in here. That way we have redundant data. So if one of them dies or if one of them starts clipping, or because the impact is too great, you have another set of data that's there as a backup. So that's kind of a real cool feature that we put into our device.
Thank you.
You're welcome.
One cool thing about our device is it's completely controllable from the computer. We can send it commands, and we can tell it to start and end a test, and it can do up to like 20 tests in a row. So that's kind of helpful for them, so they don't have to go out and retrieve it from the lab. It's always there to control and use while they're doing their research. So.
And that's waterproof.
Very much so.
It's been in the water already. It's done pretty well.
It wouldn't last very long if it wasn't waterproof.
Right, and it can withstand impact.
Yep. It's been kicked around and slammed a little bit. It holds up pretty well.
One of the main places that we're doing our testing is it's a scaled down area, so it's supposed to look like an ocean shore, but everything is scaled down to size, like I think it's 1 to 24 or something like that. And that way they can use like smaller objects to do their testing with. Our particular device, it wouldn't really matter how big it was, but it's designed for a scaled down impact, not like what a real tsunami would have.
There's actually a wave lab here at Oregon State.
Yeah, they're actually giving tours out there today. So they have a bus that's going to be running past the Kelly, and they'll take you out to the wave lab, and they'll run some waves for people and give you a tour of the wave lab, because it is the biggest wave lab in the nation.
It is
So like when New Orleans was having all those issues, like they're trying to rebuild, a lot of the testing for all the waves that they're going to design and try and rebuild New Orleans was tested here at Oregon State in the wave event out there.
And were you working with students that have a different major, like a biology major?
The people at the Tsunami Wave Lab are coastal engineers, which is kind of in the civil engineering department because they study structures. So we're working closely with civil engineers who are closest.
So what would be the advantage of this technology over, say, somebody standing on a really tall hill and watching the tsunami?
Well, it's really hard to get qualitative data out of someone watching something.
And what qualitative data does this read?
This,
One game that I like to play and I like to play
He's going to pull some data from some of our
this
tests.
is one of our tests right here. And this particular one was the module just rode the wave in. So you were expecting a kind of sinusoidal waveform.
because in a noisy
That's
room
exactly
like
what we
this,
got.
there's a
You
lot
see
of
what's green up top is the z-axis, so it was orientated with gravity. That's why it's at 9.8 meters per second squared. And then these other two axes are the x and y axes.
Like laps.
I get excited.
The module is floating like this, they're around 0 G, they're 0 meters per second, because it wasn't orientated with gravity. And then we've got a little bit of motion from the wind. You can see we're actually collecting numerical data that can be used to
means you basically have to start turning on and off.
And the lateral would be how fast it's coming in and then how fast the undertow is coming back.
And really, they use a combination of all three accelerations because it might get oriented funny. But you want to get the full acceleration value, which is, it's not just in one dimension, it might be in two dimensions. And so they would use all three sets of data to get their full measurement, and that would help them figure out how big the impact was at that moment.
So this would measure the waves to correlate with the meteorological data to show what's going on.
They take all kinds of data. This would be the acceleration. They also
very
have,
basic filtering, very cheap.
like the video games where how they make them and put the white dots on the guys, and like they have all these cameras that monitor the motion. They have golf ball size white balls that they can put in there with the same kind of tracking system. And they can see data points through the water. So that's another way to collect data. They've got all kinds of pressure sensors and other kinds of monitoring that measure the impact of the waves coming in. So this is kind of another accessory to all these